today I am going to discuss an introduction on MEMS. So what is MEMS? The MEMS means an abbreviation of micro electromechanical systems. Any engineering system that performs electrical and mechanical functions with components in micrometer range. The micro electromechanical systems is the integration of mechanical elements, sensors, actuators and microfabrication technology. The mechanical functions include sensing, moving, heating, etc. And the electrical functions include switching and designing. So that is why it is known as the electromechanical systems. The MEMS, often referred to as a microsystem technology, are fabricated using modified silicon and non-silicon fabrication technology. And it is based on a number of tools and methodologies which are used to form small structures with dimensions in the micrometer scale. So next, why MEMS for sensors? It is because of smaller in size, have lower power consumption, and it is more sensitive to input variations. And the cheaper due to mass production. And it is less invasive than larger devices. So what are its components? So the main components are microactuators, microsensors, microelectronics, and microstructures. So it is a combination of microsensors, microprocessors and microactuators, actually MEMS. So the microsensor senses the changes experienced by the system like change in pressure, change in velocity, acceleration, etc. The microsensors pass data to microelectronics for processing. The microsensors are also used to sense different physical parameters such as pressure, temperature, humidity, etc. The microelectronics acts as a brain of the system. It receives data, processes it, and makes decisions. And the microsensors pass data to microelectronics for processing. And the next one is microprocessor. It processes the input and gives a suitable output, involves the microelectronic circuits. And the next one is microactuator. It senses a signal output from microprocessor and gives a mechanical output. It acts as a trigger to activate the external device. And the interface at the input and the output. And what is a sensor? A device used to measure a physical quantity such as temperature and convert into an electronic signal of some kind, example voltage, without modifying the environment, is a sensor. And the commonly sensed parameters are pressure, temperature, flow rate, radiation, chemicals and pathogens. The sensor devices gather information from their surroundings and actuators execute given commands or act generally through highly controlled movements. Okay, so the sensor is also a device which converts one form of energy into another form of energy and provides the user with a usable energy output in response to a specific measurable input. Then next is the working principle of microsensors. That a microsensor senses the changes experienced by the system like change in pressure, change in velocity, acceleration, etc. It also senses the existence of chemical, physical or biological quantities such as pressure, force, sound, light, nuclear radiation, magnetic flux and chemical decomposition. Okay, next one, there are different types of microsensors are there. First one is acoustic wave sensor, second one is humidity sensor, and the next is displacement sensor, biomedical sensor, biosensor, chemical sensor, optical sensor, pressure sensor, and the last one is thermal sensor. These are the different types of micro sensors. Then the materials for MEMS. The materials which we are used for MEMS are metals, polymers, ceramic materials, semiconductors, and the last one is composite material. The materials are the basic things required to develop a microsensors. And the next one is fabrication. This is the basic diagram. The materials used are silicon, polymers, metals, and the ceramics. This is a basic process and it consists of three process: deposition, patterning and etching. These are the three basic building blocks in MEMS technology. First one is deposition, second one is patterning and third one is etching. The depositions that happen because of a chemical reaction or physical reaction. The deposition, first one is physical deposition. That means the depositions that happen because of a physical reaction is known as physical deposition. The physical deposition consists of a process in which a material is removed from a target and deposited on a surface. And the depositions that happen because of a chemical reaction is known as chemical deposition. The chemical deposition techniques include chemical vapor deposition, in which a stream of source gas reacts on a substrate to grow on the material's desired. And the second one is patterning. What is patterning? The patterning of MEMS is a transfer of a pattern and to apply patterned mask on top of the film by photolithographic imaging. The lithography is a widely used process in patterning of MEMS. The examples of lithography are photolithography, electron beam lithography, ion beam lithography, ion track technology, and the X-ray lithography. So, the deposition process is the ability to deposit thin films of materials on a substrate. It's known as the deposition process. There are two types of deposition, physical deposition and the chemical deposition. Okay, the deposition that happened because of a chemical reaction is known as chemical deposition. The depositions that happen because of a physical reaction is known as physical deposition. Okay, then the patterning means to apply patterned mask on the top of the film by photolithographic imaging. The examples are photolithography, X-ray lithography, and the beam lithography, etc. Next one is etching. There are two types of etching, wet etching and dry etching. To etch the film selectively to the mask, a MEMS process is usually a structured sequence of these operations to form a actual devices. So first one is wet etching. Wet chemical etching consisting in selective removal of material by dipping a substrate into a solution that dissolves it. So it consists of a selective removal of material by dipping a substrate into a solution that dissolves it. So the chemical nature of this etching process provides a good selectivity. And the next one is dry etching. Dry etching can be done in three ways, and they are reactive ion etching, sputter etching, and the third one is vapor phase etching. So etching means to etch the film selectively to a mask. The next one is application of MEMS. There are various applications. So the first one is safety. Example, airbag deployment system and anti-lock braking system. That means position sensor. Suspension systems, displacement, position and pressure sensors that we are used. And the last one, the object avoidance, the pressure and displacement sensors. The application of MEMS in biomedical industry. So these are the applications of MEMS in biomedical industry. The disposable blood pressure inducer, angioplastic pressure sensor, that means to monitor the pressure inside the balloon once it is inside the blood vessel. Okay, the third one is respirators, and the fourth one is lung capacity meters, barometric correction instrumentation, medical process monitoring, and the kidney dialysis equipment. Okay, there is the figure shows an implantable blood pressure sensor. Say pressure sensor. It's a blood pressure sensor, implantable blood pressure sensor. Okay, so a MEM device can be implemented in the human body. The MEMS surgical tools provide the flexibility and accuracy to perform surgery. Okay, next one is application of MEMS in automobiles. To make the automobile safer and more comfortable for riders, and to meet the high fuel efficiency and low emission standards required by the government. Make the automobile smarter for the consumer's need. Smart means with various sensors that we are used to detect the environment or road conditions. Or the micro sensors and actuators allow the makers to use smaller devices in effective ways. So these are the applications of MEMS in automobiles. So example. So the MEMS sensors in automotive applications. This is an example. These are the principal sensors. The 10 sensors are there. The first one is manifold or temperature manifold absolute pressure sensor. Second one is exhaust gas differential pressure sensor. And the third one is the fuel rail pressure sensor. And the fourth one, the diagram, the fourth represents the barometric absolute pressure sense. The fifth represents the combustion sensor. And the sixth represents the gasoline direct injection pressure sensor. And the seventh one in the figure shows that the fuel pressure sensor, and the 8 shows that the engine oil sensor, and the 9 the transmission sensor, and the 10 the tire pressure sensor. These are the various sensors that we are used in automotive applications. Okay, so the next one is in microphones. The MEMS microphones is also called the microphone chip. It is widely used in the present day communication world. So MEMS plays an important role in microphones also. Then next one is in military. The micro electromechanical system MEMS technology helps projectiles to reach their targets accurately. Okay, so it is also used in for military purpose. So the MEMS is also used in optical switching technology, in which switching technology and alignment for data communication is done. Okay, these are the various kinds of applications based on MEMS. Then next one is the advantages of MEMS. What are the advantages of MEMS or micro electromechanical systems? It minimizes the energy and materials used in manufacturing, and it improved the reproducibility. It also improves the accuracy and reliability. It also increases the selectivity and sensitivity. The cost and performance is an advantage, and very small size, mass and volume, and very low power consumption. The disadvantages are very complex design procedure, and the micro components are costly compared to the macro components. This is a basic outline or the introduction about MEMS. Thank you.